Welcome to Luca and Miguel. Enjoy the video.
You start by preparing the environment and data. Install Python 3. 8+, pip packages like NumPy and Torch, then import them. Load a CSV or Sklern toy set, split 80/20 for train versus test, and normalize features to 0, 1 or means 0 std1. Once done, set a random seed and choose device CPU or GPU. Now create dataset and data loader with batch size 32. This gets you ready to define the network architecture. You now implement the model class. Declare input size, 1 or 2 hidden layers, re-LU activations, and an appropriate output layer. Initialize loss, MSE for regression or cross-entropy for classification, and choose Atom or SGD with LR0, 0, 0, 1. Then write the training loop. For each epoch, iterate batches, run forward pass, compute loss, call loss. Backward, step the optimizer, and 0 grad. Make sure to monitor loss and accuracy each epoch. Log every 10. You finish by evaluating and persisting the model. Switch to model. Eval and wrap inference in no grad to compute accuracy or RMSE on the test set. Once satisfied, save weights with Torch. Save or model. Save and reload to verify identical predictions. If results are poor, check common issues. Learning rate too high, batch size too small, mislabeled targets, or data leakage between train and test. A single tip: reduce LR by tenfold and retrain. Often this stabilizes training and resolves exploding loss.
Thanks for watching and please subscribe. It's the best investment you'll ever make.